Unit 4, Quadrilaterals and Polygons, Lesson 2, Parallelograms, Part 1. Your objectives for this lesson are to classify quadrilaterals, to name properties of sides, angles, and diagonals of parallelograms, and to apply the properties of sides, angles, and diagonals of parallelograms to solve problems. Okay, so we're going to start off with the quadrilateral family tree. I do expect you to know this. We are going to be talking about different types of quadrilaterals. So I've already filled in on top quadrilateral. This is your general term for any four-sided polygon. So any polygon with four sides. On this side, we have the parallelogram, which we'll be looking at more today. And subsets of parallelograms, you have rectangles and rhombuses, or rhombi. I'm just going to write rhombus here. So maybe I should write singular rectangle there. And the square, which is a special case of both the rectangle and the rhombus. Okay, leaving the parallelogram side of the family tree, we have trapezoids. There is a special type of trapezoid called the isosceles trapezoid. That word should be familiar from triangles, isosceles. And lastly, the kite. And we will look at all of these quadrilaterals during Unit 4. Okay, but starting back up with parallelograms, that is our focus for today. A parallelogram is a quadrilateral that has two pairs of parallel sides. So you can see AB and DC are parallel to each other, marked by these arrows, which mean parallel. And AD and BC are parallel to each other, marked with these arrows. So opposite sides are parallel. Our first properties of parallelograms. So opposite sides of a parallelogram are congruent. Opposite sides are congruent. Opposite angles are congruent. And consecutive angles are supplementary. So I think I have a diagram here. Yes, I do. Opposite sides are congruent. That means that AB and CD are the same length. So if this was 10, this would be 10. And if this is 8, this is 8. Okay. Could also just mark these with some congruence markers. Okay, remember we use 2 after you've already used 1 tick mark. The opposite angles are congruent, so A and C are congruent, and B and D are congruent. The fact that consecutive angles are supplementary means that if angle A is 120 degrees, angle B will have to be 60, because 120 and 60 equal 180. Okay, and the last property on this page says that if a parallelogram has one right angle, then it has 4 right angles. And we'll look at that more when we get to talking about rectangles. But these properties you do need to memorize. You need to know them. Example 1, if ABCD is a parallelogram, find the value of each variable. Okay, so I have 2 variables. It looks like I have an A and a B. I'm going to start with A, and I know that opposite sides of a parallelogram are congruent. That means that they're equal. So 2A is equal to 34, okay? Because 2A is on this side, 34 is on this side. Opposite sides are congruent. From here, all I have to do is divide by 2. So A equals 17. Okay, Now I need to find B. Well, I have some opposite angles, 8B and 112, and I know that opposite angles of a parallelogram are congruent. So I'm going to say 8B equals 12. To solve for B, all I need to do is divide by 8. So B equals 14. And this is my answer. A is 17 and B is 14. If I wanted to find angle B, that would be very easy. So I know that B and C would have to equal 180 degrees. So I could say B plus 112 equals 180. And then just subtract 112. And I would get B equals 68 degrees. Okay, so that's one instance of each of the three properties we just looked at, except for the 90-degree angle property. Okay. Next up, if a quadrilateral is a parallelogram, then its diagonals bisect each other. That means that they cut each other in half. If a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. So a parallelogram is really two congruent triangles pushed together. And let's look at this here. So we have our parallelogram and the diagonal. So a diagonal goes from one corner to another corner, but not along the side, so through the inside. And since the diagonals bisect each other, that means that this center point, maybe I'll call it E, is the midpoint of AC and DB. So E is the midpoint. So AE is congruent to EC, and DE is congruent to EB. Okay, that's what that first property means. And the second property that says the quadrilateral is split into two congruent triangles means that triangle ABD, so that's this triangle on the left, is congruent to triangle CDB. Okay, so that's this triangle is congruent to this triangle. You can see that they do look alike. And also, we could say triangle BAC is congruent to triangle DC, wait, not DCB, sorry. So BAC is congruent to triangle DCA. Okay, so if I move this, we highlight again. So BAC is congruent to DCA. Okay, so those are also congruent triangles. Example 2, find the value of x and y in parallelogram ABCD. Okay, so we have parallelogram ABCD with E. Remember, E is the midpoint of each diagonal. So that means that 18 and 4y are congruent, and 6x and 24 are congruent. So let me set up those equations. 18 equals 4y, and 24 equals 6x. To solve my first equation, I'm just going to divide by 4 to get y by itself. And I get y equals 4.5. And over here, I need to get x by itself, so I'll divide by 6. And I get x equals 4. So that's all you got to do. Set the two halves of the diagonals equal to each other. And that concludes lesson 2, part 1.